Hello, my name is Jessie Saunders, and welcome to our poster about the Plum Earthquake Early Warning Algorithm. Plum stands for Propagation of Local Undamped Motion, and it takes a ground motion-based approach to early warning, where observations of ground motions at seismic stations are used to directly forecast shaking elsewhere. There have been some questions about Plum's alerting behavior for small magnitude earthquakes that we aim to address with our poster. Small magnitude earthquakes are tricky for earthquake early warning, because while they can produce potentially damaging ground motions, the spatial footprint of these ground motions is usually too small for early warning systems to be able to issue timely alerts. Due to these timeliness concerns, source-based early warning systems like the Shake Alert system impose magnitude threshold criteria on their alerts. For Shake Alert, a minimum magnitude estimate of magnitude 4.5 is needed before an alert can be issued to the public. Because Plum does not estimate magnitude as part of its alerting process, Plum may trigger alerts for magnitude less than 4.5 earthquakes that produce strong ground motions at seismic stations. This begs the following questions. How often might this happen, and how might it impact public perception of earthquake early warning in the United States? In this poster, we examine Plum's detection and alerting performance on real-time data from this year to determine how Plum behaves during small magnitude earthquakes. Plum has been running on real-time West Coast data since 2019 for internal research purposes. And while Plum does not issue early warning alerts to the public, we can look at the real-time communication logs from Plum to internal Shake Alert servers to determine what the real-time alert regions would have looked like. Plum's detection and alerting strategies for US West Coast earthquakes are tailored to correspond with early warning targets for the Shake Alert system. Plum takes a two-station approach to earthquake detection, where modified Mercalli intensity 4 shaking must be observed at one station and be confirmed by observation of MMI3 shaking at a neighboring station within 15 seconds of the first station's observation. Once a Plum detection is issued, Plum starts sending MMI predictions on a 0.2 by 0.2 degree grid that is updated every second, where our preferred alerting strategy is that grid cells predicted to have MMI above MMI4 are issued alerts. Not all Plum detections will result in Plum alerts. Because Plum alert regions are determined by the real-time MMI prediction grids that are updated each second, if MMI4 shaking is no longer occurring by the time an earthquake detection is confirmed by MMI3 shaking at a second station, no alerts will be issued by Plum. This behavior is more likely to be seen in small events due to their short shaking durations. Plum's ability to detect an earthquake depends on the station locations relative to an earthquake source. Taking the Shake Alert network distribution and assuming an earthquake source depth of 8 kilometers, as well as median expected shaking distributions from ground motion models, we can compute the minimum magnitude detectable by Plum for earthquake sources throughout the Shake Alert reporting region. When we compare this map with the earthquakes that Plum did and did not detect this year, we find that Plum behaves exactly as expected given this distribution. Of the 291 magnitude 3 and larger earthquakes that have occurred in 2021 through August 5th, 20 produced ground motions large enough at seismic stations to be detected by Plum, which we highlight in more detail in the table at the center of our poster. Of these 20 earthquakes, Plum alerts for MMI 4+ shaking would have been issued for 13. Plum issues alerts for all 4 magnitude 4.5 and larger earthquakes that produce significant onshore shaking. All magnitude less than 4.5 earthquakes that had Plum alerts are widely felt, with 5 of these earthquakes having over 1,000 reports in the USGS Did You Feel It system. For comparison, Shake Alert issued public alerts for 8 of these 20 earthquakes and for only 3 of the 4 magnitude 4.5 and greater events. At the bottom of our poster, we show maps comparing the observed ground motions with the Plum alert regions, as well as the Shake Alert regions for some of the earthquakes in our dataset. As Plum prediction regions surround stations observed to have strong ground motions, Plum alerts include the locations that experience significant shaking levels. This is not necessarily the case for Shake Alert regions if there are large errors in the magnitude or epicenter estimates, such as during the magnitude 6 Antelope Valley earthquake. We find that for 2 of the largest earthquakes in our dataset, the magnitude 6 Antelope Valley and the magnitude 5.1 Petrolia earthquakes, the inclusion of Plum would have improved the real-time alert performance of the Shake Alert system. And as both Plum and Shake Alert issue alerts for magnitude less than 4.5 earthquakes, we suggest that informative post-alert follow-up messaging is key for ensuring positive public perception of earthquake early warning in general. Thank you for stopping by our poster.